Alright guys, today what we're going to do is we're going to look at some shortcuts for finding areas of triangles. Now I know you guys all learned in geometry in 8th grade how to find the area of a triangle. So we're just going to find some simpler and shorter ways to do these. So let's say you were given a triangle, and let's say you were given two sides of that triangle. Let's say I knew that this side the base was 13, and I knew this other side was 15. And then it gave me another angle. Let's say that angle was 71 degrees. You guys know that the area of a triangle is 1/2 times the base times the height. Well, I already know the base is 13. But what I don't know is the height. So I would need to solve for that. So what I'm going to do is I'm going to solve for my height. So that height, I could use basic trig because I know that has to be a right angle. And I would know that the sine of 71 degrees would be equal to my opposite side, which is my height that I don't know, over my hypotenuse, which is 15. So that means that my height, let's go ahead and call that h so it's not confusing, would have to equal 15 times the sine of 71. So that would mean my formula for area here would be 1/2 times the base, which is 13, times 15 times the sine of 71. Now there actually is a formula that we can use. It's going to make this a little bit simpler. And that formula is that my area equals 1/2 times A times B times the sine of C. Now A, B, and C, again, just like the law of cosines, are interchangeable. What's important here is that C is the angle between my two known sides. And this is just a shortcut way of using that information I just found, because that's exactly how I solved it. It's just combining it all together in one step. So let's take this example down here. I know that I have a triangle, so let's go ahead and draw it. This is A, B, C. Angle A is 71 degrees, side C is 15, side B is 13. And I know one angle and the two sides around it. So this is a case of side, angle, side. So that's when I'm going to want to use this formula. I'm going to use this formula when it's side, angle, side. So what I'm going to do here is I'm just going to set up my formula. I know it's my area equals 1/2. And A and B, remember, those letters are interchangeable. It's just the two sides next to the angle. Those two sides are 15 and 13. And my angle is in between those, which is 71 degrees. So all I need to do, type this all in my calculator, and it's going to give me my answer. And again, my mode should still be in degrees. But if I type that all in, I should get an area of 92.19. So again, we'll use this formula when given side, angle, side. But another thing that's kind of helpful to look at, if you look, I know one angle, and each letter is a different letter. That's also kind of a clue for when I can figure out when to use this formula. Now, if I'm not given some of that information, remember, you can always use the law of sines and cosines to solve for some of that information you're not given. Alright, so we do have one more shortcut formula. This is called Heron's formula. And this is the formula that we'll use if I want to find the area of a triangle, and instead of given side, angle, side, if instead it gives me 3 sides. So this is it's a really big formula, but the thing that you need to remember here is that S stands for the semi-perimeter. And semi-perimeter is kind of a semicircle is half of a circle, so the semi-perimeter is half of the perimeter. So I would just find the perimeter of my circle and divide it by 2. So let's do an example here. It tells me I need to find the area of this triangle, and it gives me 3 sides. So this is going to be triangle JKL. Side J is 8, side K is 11, side L is 7. So in order to use this formula, I need to find what S is first. So S, I'm trying to make those not look like 5s, is going to be 8 plus 7 plus 11 divided by 2. So that's going to give me a semi-perimeter of 13. So I'm just going to plug these numbers into the formula. So it is the S times, and remember A, B, and C are interchangeable. What matters is just each one is a different side. So I'll do semi-perimeter minus one side, semi-perimeter minus another side, semi-perimeter minus the third side. Now if I were you guys that don't want to type this in the calculator, make sure you don't make a mistake, I would type in everything that's inside the square root first. So I would just find all of that and then take my square root in a separate step just to make sure I don't have any mistakes with parentheses. But no matter how you do it, as long as you type in your calculator correctly, I should get an answer of 27.93. Alright, so that's a way of finding area, a shortcut for area when I know three sides. Alright, so the last one we're going to look at is just a little bit of a tougher one. And let's just say I'm given a triangle, or instead of a triangle, I'm given a quadrilateral. And I need to try to find the area of this quadrilateral. So this one's going to be a little bit different because I need to split this up into triangles in order to be able to find the area. So what I'm going to do to start off here is I'm going to just draw a line down the middle and divide this into two triangles. So triangle 1, let's do that one first. So if I look at triangle 1 here, I'm given two sides and the angle in between. So it's very easy for me to find the area of the first triangle. I know that that's going to be 1/2 times one side times the other side times the sine of the angle in between, because I'm given side angle side on that triangle. So that triangle has an area of 54.16. So that one's pretty simple. Now the second one's a little bit tougher. So if I look at my second triangle here, I don't have enough information for my second triangle. I know two sides, but what I really need is the distance that I have on that black line that I drew. So what I'm going to have to do is I'm going to have to solve for that x. So what I can do to solve for that x is I can look back at that first triangle. I'm given a side, angle, and a side. So I can set up the law of cosines to find what x is. So I know that has to be 12 squared plus 15 squared minus 12 times 15 times the cosine of 37. So if I work out the law of cosines, as long as I do everything right, I should get an x value here of 9.03. So now I know how much that value is. So now this top triangle, I should have enough information to solve it, because now I know three sides, so I can solve for the area of triangle 2 using Heron's formula. So in order to do that, I'm going to need to find the semi-perimeter. So the semi-perimeter of the second triangle is going to be 13 plus 11 plus that third side, which we just found is 9.03. I'm going to divide all those by 2, so I get a semi-perimeter of 16.52. So now I can set up that formula. It's the semi-perimeter, and then I subtract the semi-perimeter, or I subtract each side from the semi-perimeter. So it's a lot of numbers to write down, but as long as I find that missing side, it's really easy for me to use this formula to find the area of that triangle. So again, the hardest part at this point then is just making sure I type this all into the calculator right. So if I type that all in correctly, I should get an area for my second triangle of 48.71. So if I know the second triangle has an area of 48.71, the first triangle has an area of 54.16, my total area is simply those two numbers added together. Which gives me a total of 102.87. So that's it, just a few shortcuts for finding area of triangles.